Hello everyone, I'm Sheikh Urfa from ECC. Today my topic is Introduction to Registers. Introduction to registers is sequential circuit stores information using memory elements. Registers are a key type of sequential circuit used to store and transfer binary data. Definition of a resistor. A resistor is a group of flip-flops used to store binary information. Each flip-flop stores one bit. For example, A is 4-bit resistor has 4 flip-flops. There are 10 types of registers. There are first one is buffer register, second control buffer resistor, shift right resistor, shift left resistor, bidirectional shift resistor, CISO resistor, SIPO resistor, ISO resistor, and PIPO resistor, and finally universal shift register. Let us know what is a resistor. A shift register is a group of flip-flops connected in series to store and shift multiple bits of data either left or right with clock pulses. The register that shifts the bits to the left is called shift left register. The register that will shift the bits to the right is called shift right register. Based on the data load and retrieval from the register, the registers are classified into four types. They are CISO, CISO register, SIPO register, PISO register, and PEPO register. SIPO is series in series out. SIPO is series in parallel out, and PISO is parallel in series out. PEPO is parallel in parallel out. Buffer register. A buffer register in digital electronics in a storage unit that holds binary data bits using a series of D flip-flops. With each flip-flop storage 1 unit, data is loaded into a buffer register at each clock tick with outputs matching input bits. At each reading clock edge, its primary function is to act as a temporary storage area for data being transferred between devices and components to match different speeds of faster and slower devices. A control buffer register. Buffer register lack control over inputs, causing uncontrolled outputs. To fix these, control buffer registers are used. In this design, tri-state switches are used to control the operation of loading and or retrieval of the data to from the buffer register. Here one has to pull the lever or WR bar control light blue line low in order to restore the data into register, while RD bar control line red line shows should be made low to read the data. And this is the diagram. Shift right register. The register that transfers or shift input data rightwards is called shift right register. When the rising or falling clock edge arrives at the when the stored bit shift right were according to the 1 bit position per clock pulse. Data is entered into the register from left side and data is retrieved from the right side. And here the diagram shows the process. Shift left register. The register that transfers or shift input data leftwards is called the shift left register. When the rising or falling clock edge arrives then the stored bits shift leftwards. According to that, it is a clock pulse, 1 bit position clock pulse. Data is entered into the register from right side and data is retrieved from the left side. Bilateral shift register. This type of register allows shifting of data either to the left or either to the right. It can be implemented by using logic gate circuitry that enables the transfer of data from one edge to the next stage to the right or to the left, depending on the level of control. The right or left is a control input signal which allows data shifting either towards right or towards left. The right or left is the control input signal is low. The data in the register shift towards the left. The right or left is the control input signal is high. The data in the register shift towards the right. And this is SISO register. The serial in, serial out. Shift register accept data 1 bit at a time through a single input line and output data serially. Data enters and leaves 1 bit at a time in a serial sequence, typically made of multiple D flip-flops connected in series and synchronized by a common clock. The figure shows the process. And SIPO register, a serial in parallel out. SIPO shift register accepts the data through 1 bit at a time through a single input line and output data parallelly through the multiple lines. Data in input 1 bit at a time and output all stores bits in parallel. Here the diagram. PISO register, a parallel in, serial out. Shift register accepts data multiple bits at a time through multiple input lines and outputs data serially through a single line. Here there are 4 flip-flops used in this PISO register. PIPO register, a parallel in, parallel out. Shift register accept data multiple bits at a time through multiple input lines and outputs data in parallelly through multiple lines. Universal shift register, the final register is. A universal shift register is an n-bit register that supports both left and right shifting as well as parallel loading, using n flip-flops and n multiplexers with shared selected lines to control the data flow. It combines the feature of bidirectional and unidirectional registers, enabling versatile data manipulation like shift left, shift right, parallel load, and hold. Advantages of registers. Registers have many advantages. Some of the advantages of registers is fast data access. It accesses the data very fast compared to other. Simple integration with ALU and memory. It integrates the memory as well as ALU very simple way. And third one is provides synchronization and stability in digital circuits. And these are the advantages of registers. Advantages, there are some advantages. The first advantage is limited storage capacity. It has only limited capacity of storage. It does not store much data. And second is hardware cost increases with bit width. As the cost increases, the bit width also increases. The cost is if the cost is more, this is one of the advantages of registers. And the third one is not suitable for large scale memory storage. It cannot store large scale of memory. It is used to store some small scale memory elements like 4 bits, 2 bits. And finally, the conclusion is registers are vital sequential elements. The second one is enable temporary data storage and manipulation. Stores only the temporary data storage. It does not store the data as permanent. And the third one is foundation of memory, counters and digital controls. It founds the memory as counters and digital control systems. Memory can be stored as many types. These can be stored only temporary memory, but cannot store the permanent memory. There are counters and control systems. This is the foundational base for the counters and control systems. Finally, thank you.